Welcome to this video. I'm HasPhysics and today we are going to be going over speed of a transverse wave on a string. So how do you calculate it? This is the formula used to calculate the speed of a transverse wave on a string, where v equals root t over mu, where v equals speed, t equals tension of the string, and mu equals mass per unit length of the string. So now we go into the example exam style question where it states, the strings of one type of harp are made from nylon of density 1070. One string has the diameter of 1.14 millimeters. Show that the mass per unit length of the string is about 1.1 times 10 to the power minus 3. So, we know that the formula of mu is mass per length, as it says in the name. And we can also rewrite the mass in terms of density and volume. And because density times volume equals mass, we can just write it as rho multiplied by v over L. And because the string is a cylinder, we can rewrite the volume as the volume of a cylinder, which is pi r squared multiplied by L. And we just write the rest of the formula down, which is multiplied by rho and divided by L. And because there's a L on the top and bottom of the fraction, we can just cancel it out. So the final formula would be pi r squared rho. And so now we just substitute the values in. So pi, and because r is the radius and we're given the diameter, we need to divide it by 2. And because it's in millimeters, we need to times it by 10 to the power minus 3 squared, and we times that by the density, which is 1070. And when you do that, we get 1.09 times 10 to the power minus 3. And that's very close to what we have over here, so that means we are correct. So now we go into part II. When the middle of the string is plucked, a note of frequency 440 Hz is produced. Calculate the tension in the string. Length of the string is 41 centimeters. So this is where we use the formula from the previous slide, which is v equals root t over mu. And because in this question we have the frequency, but we don't have that here. So here we use another formula, which is v equals f multiplied by lambda, where f equals frequency and lambda equals wavelength. And because they are both equal to v, we can just make them equate to each other. So it will be root t over mu equals f multiplied by L, multiplied by wavelength. So we have the f, but we need to find the wavelength. And to do that, we have the formula L equals, it's not really a formula, but we just need it. So L equals wavelength divided by 2. And because the length is 41, and we want to rearrange to get wavelength, it will be 2L equals lambda, as we multiply both sides by 2. So what we get is 2 multiplied by 41, but it's not 41 because we want to change that to meters. So we divide it by 100, so it is 0.41. And that is equal to lambda. So lambda equals to 0.82. So when we do that, we get, so root t over mu equals f times wavelength. So we know the f, which is 440 Hz, and now we know the wavelength, which is 0.82. So we just multiply them together. And that is 360.8. So now we want to find the tension. So we want to rearrange to make t the subject. So when we do that, we get 360.8. And because everything is rooted, we want to square both sides. So we get 360 squared equals t over mu. And because we want t by itself, we times both sides by mu. So 1.1 times 10 to the power minus 3 times 360.8 squared, and that is equal to 143 newtons. And because tension is a force, the unit is newtons. And there you have it. So now we go into the second example exam style question, where it states, when a string is plucked, a standing wave is set on the string. A thicker string produces a note with lower fundamental frequency than a thinner string of the same material. Justify this statement. So the first point is, the thicker string has a higher mass per unit length, and the wavelength of each string is the same, and the length of the string is also the same. So we can use the formula V equals root T over mass per unit length, which is mu. And because it's asking for the frequency, we also need to use the other formula, which is V equals F multiplied by lambda. And we make them equate to each other. So F lambda equals root T over mu, because they're both equal to the same thing. So we could just make them equate to each other. And then now we need to compare the mass per unit length with the frequency. And from this formula we can see that the relationship is F 1 over root mu, because we just want the frequency and the mass per unit length, and we want to compare them. So a thicker string has a higher mass per unit length. So if the mass per unit length increases, and because it is in a fraction, if when the denominator increases, that means that the frequency has the opposite effect, so the frequency decreases. Because if you have a bigger number in the denominator, that means that the number gets smaller. So that means that the frequency will decrease. And so therefore, the statement is correct. And there you have it. So thank you for watching this video. I hope you have learned something from this video, and it would be really appreciated if you could share this video and subscribe. Have a fantastic day.